Welcome back, everybody, to section 2.4. I'm going to go on and move to the examples that we talked about using the algorithm we talked about in part 1, the steps to graphing. So let's go ahead and apply it to example 2. Here we're asked to graph 2x plus 2y is greater than or equal to 6. As we talked about before, the first step, in my opinion, this is the best way to do it. It's recommended to get y by itself. We want to get it into slope-intercept form, so we're going to go ahead and do that. Subtract 3x from both sides. We have 2y is greater than or equal to 6 minus 3x, and we're going to divide by 2 to both terms on the right side. We get y is greater than or equal to 3 minus 3 over 2x. Okay, very important that anytime we divide or multiply by a negative, we need to flip the sign. Okay, the second step is graphing that line. Okay. And we're just going to use dots at first. So the y-intercept is 3. And then the slope is negative 3 over 2. That means I'm going to go down 3 to the right 2. 1, 2, 3, 1, 2. There's my dot. I'm going to do this multiple times. I think that's important to do. But it's all individual preference. Okay. Now I make a couple dots. And now what I'm going to decide is step 3 is I decide what my boundary is going to be. Because it's greater than or equal to, I'm going to be using a solid line. That means it can include those values indicated. Just to give you a reason why, I'm going to plug in this point right here, which is the first one we did, the y-intercept, and it was 0, 3. So if I plug in 3 for y and 0 for x, you'll see that we get 3 is greater than or equal to 3. That makes a true statement, so it can be included in our solution, meaning all those points along the line can be included. I'm going to connect the dots with a solid line. Okay, well, maybe not. All right, let's get this going. Boom. There's our solid line. Okay, now we're on to, we don't really need to do step 4 if we have it in slope-intercept form. We're going to go ahead and jump to step 5 where we determine where we shade. So we shade above if it's y is greater than, we shade below if it's y is less than. Okay, I didn't really talk about y, but I'm going to go ahead and, whoops, I don't know what I just did. I didn't talk about y, but I'm going to go ahead and shade because it's y is greater than above. So you can see what our graph looks like. Okay, our solution set. These are all solutions. Anywhere the purple touches, anywhere the light touches is your kingdom. Anywhere the purple touches is your solution, and we're done. Now, why is that true? Well, I'm going to go ahead and show you step 4. We can test any point. Okay, so for example, if we wanted to test this point right here to see if it's a solution, that's the coordinate 1, 2, 3, 4, 5, 6, 6, 0. Okay, I'm going to show why that's the solution and why we should graph on that side. So we're going to plug in 6 for x. I'm going to go ahead and go back to this original one here. So 6 for x plus, and then 0 for y. Is that greater than or equal to 6? I get 18 plus 0. Is that greater than or equal to 6? 18 is greater than or equal to 6, so that is a solution. Okay, so it just so happens that if you have y is greater than, it's going to be above the line. So anytime you have above the line, that means you pick a point and you just want to shade above that point. Okay, some people get confused because they think left and right of the line. Don't think that. Just think above or below a point and shade everywhere that it touches. Okay. All right, moving on to the second one, we're going to do the same thing here. This is, you're going to see, is a little bit different. Okay, this is not in, doesn't have a y. So we can't really get into slope-intercept form, but we can get it into a form we recognize, which is x is less than 4. We can't get the x by itself. This is a vertical line. Okay, so we're going to do the same thing. We're going to graph. We're going to go to x is 4. This is the x-intercept, 2, 3, 4. And we're going to put a dot everywhere that x is 4. This happens to be a vertical line with an undefined slope. Okay, so we have those kind of started here. Now we need to decide, is this a boundary, solid boundary, or a dashed boundary? This is a dashed boundary because it's less than and not... ooh, this is really ugly. This is less than and not less than or equal to. So we just want to indicate that this is not a solid and that the solutions are not on the line. Okay. Now we have to decide, is it above or below the line? Well, there's no above or below because it's a vertical line. So what do? Well, because it's x is less than, this is kind of like a special case. Okay, x is less than. We wouldn't shade above if it was y is less than. We would shade below, kind of like in the negative direction. So what would be the negative direction for x is less than? It would be to the left. So we're going to shade to the left here of this guy. Okay, so everywhere x is less than 4 is to the left of 4, and there's our solution. Okay, moving on to example 4, we have 2 that we need to graph here. So we need to solve for, it looks like there is 2 x's, so we're going to have 2 vertical lines here. Okay, I see. We have 2 different scenarios that we need to talk about. One is we have 2x plus 4 is greater than or equal to 5. So we need to solve for x here. We subtract 4. We get 2x is less than or equal to 1. So we have x is greater than or equal to 1/2 after we divide by 2. Okay, and then we also have x is greater than 1. Okay, so what we're going to do here is we are going to graph x is greater than, well, we have to graph both these lines. So x is, I'm going to use different colors. So for this one, I'm going to call this one the green one and this one a blue one. Now I'm going to jump ahead. I know I'm going to be using solid lines for both because they're both greater than or equal to. So I'm going to go ahead and graph my 1 here. This is 1. It's a vertical line. Okay, and then my 1/2 is going to be right next to it. But on the 0.5, I'm just making this 1/2. Okay, this is going to be a little messy. Maybe I'll scale it in just a second. Now we're talking about the values for both of these that are greater. So the first thing we're going to do is we're going to shade the green. Greater than means we're going to the right for x. So we're graphing, so x is greater than, we're graphing to the right, the positive values, everywhere that it's bigger than 1/2. So we're talking about here. Whoops, that's kind of gross. Okay, whatever. Ooh, not doing a good job here. Sorry, just have to get it right. Okay, so he's doing better. Okay, there we go. Everywhere it's bigger than 1/2. Okay, and now I have to do the same thing for blue. Everywhere it's bigger than 1. And that looks like this. Okay. All right, so I graphed both of these. Now, it says and. So what does that mean? Well, that's where we're looking for overlap. If you remember, we're talking about this when we talked about inequalities before. This is where we're talking about overlap. So where do the 2 colors blend? Okay, well, they blend in this area. Okay, they blend everywhere this guy is. Okay, so if we were to graph the solutions, our solution would just be where the 2 shaded regions touch. So I'm going to go to purple here. They all overlap along this line. X is greater than 1. And in here, this is where they overlap. So that is our solution set. This little green sliver is not part of our solution set because it's not overlapping. Okay. Now we have the same thing. We have these 2 lines here. I really wish it wasn't 1/2 because it was a little bit easier. But whatever. And we're going to get the same thing when we solve. We get x is greater than or equal to 1/2, and this is still x is greater than or equal to 1. And this is just to show you the difference between and or. So we have x is greater than or equal to 1. We're going to graph the same lines here. We have, I'm going to scale it up a little bit. I'm going to call this 0.5 and this 1, just so you can see it a little bit more clearly. Really doing myself a favor, if anything. Okay, so here's 1. This is x equals 1, and then I'm making x equals 1/2 right next to it. Okay, so then you have x equals 1/2. Well, it's actually greater than, sorry. Greater than 1/2. Greater than or equal to. Okay. So now what we're going to do here is we are going to shade, okay, just like we did before. So I'm just going to shade both. That's one of our rules here. Shade, 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 shade. Okay, there's the blue one. I have to shade for both, so I go to the green one now. I shade this. Oh my gosh, what is wrong with this green one? Okay, I shade the green one. Shade, 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 shade. Now, it says or. This one looks way better. It says or. Okay, so we can clearly see the overlap, but because it says or, that means we want to include all the shaded. Okay, this is the union. We want all possible values. So we don't want to exclude anything. We're not interested in just the overlap. We want all the possible solutions. So guess what we're going to do? We're going to include all the possible solutions. We're going to start from here. Okay? And we're going to include everything this time. So there's a slight difference here. We're including just a little bit more. Okay? But or is the union all possible solutions, and is overlap a little bit distinction. These are compound inequalities that we're graphing. And that's all there is to it. So hope you enjoyed this video that we got to see a couple examples, and I'll look forward to seeing you next time on Wes Explains Best.